Hello everyone, today I will be explaining the reaction mechanism. So first of all, the reaction mechanism is a series of steps in which a reaction takes place. Now for a reaction mechanism to be acceptable, it has to satisfy two requirements. The first requirement is that the sum of the steps must give us the overall reaction, and the second requirement is that the rate law must match the slowest step of a reaction. Now before I start with an example, I'm just going to give you guys two important definitions that you have to know, an intermediate and a catalyst. An intermediate is a substance formed in one step of a reaction and then used up in another. And a catalyst is a substance that is used up in one step and then formed in another step. Now, something important you have to know about the intermediate and the catalyst is that you would never usually find an intermediate or a catalyst in the final overall reaction, because something that is formed in one step, which would be on the right side, and then used up in another on the left side, you can cancel those two out. And the same thing with the catalyst. And something else important that you have to know about the intermediate is that you can never write a rate law in terms of an intermediate. And that's very important, so keep that in mind. Now let's do this simple example. They gave us two steps and they told us which one is slow and which one is fast, and they gave us the overall reaction and the rate law. Now we're supposed to find out if the reaction mechanism is acceptable or not. Now to find out if a reaction mechanism is acceptable, we said it must satisfy two requirements. The first requirement is that the sum of these two steps must give us the overall reaction. Now let's check if that requirement is satisfied or not. So let's add it. H2 plus H2 will give us 2H2, and there's nothing on the left side for H2 to cancel out with. So in the overall reaction, it's supposed to be 2H2, and it is. And 2NO, there's nothing for it to cancel out with on the right side, and there's nothing for it to add with on the left side. So it's supposed to stay 2NO. So that's also correct. Now for N2O, we can cancel out with the N2O on the right side, and it's an intermediate, so we're not supposed to find it in the overall reaction, and we don't. So till now, the requirement is satisfied. But let's check this nitrogen and these waters. Now for nitrogen, there's nothing for nitrogen to cancel out with on the left side, and there's nothing for it to add with on the right side, so it's supposed to stay as N2, and it is, so that's also correct. And finally for water, there's two waters on the left side and none on the right side, or there's two waters on the right side and none on the left side, so the two waters would add up and would give us 2H2O. So the sum of these two reactions does give us the overall reaction, so the first requirement is satisfied. Now let's check the rate law. As I said in the previous video, that the rate law is you only look at the slow step. Now we look at the reactants of the slow step. The reactants are H2 and NO, and NO has a coefficient of 2. So the rate law should be R equals K H2 times NO to the power of 2. And it is, so the condition is satisfied. So this reaction mechanism is acceptable. Okay, so now let's do number 1 and 2. A mechanism for the reaction 2NO2 plus Cl2 gives you 2NO2Cl is suggested below. Step 1, the slow step, NO2 plus Cl2 gives you NO2Cl plus Cl, yeah. And step 2, the fast step, NO2 plus Cl gives you NO2Cl. Knowing that the rate law was determined experimentally to be R equals K times NO2 times Cl2, deduce whether the mechanism is acceptable or not, and justify. So as I said before, for a mechanism to be acceptable, it has to satisfy two requirements. The first requirement is that the sum of the two steps should give you the overall reaction. Now let's try adding them. If you add these two NO2s, we would get 2 NO2, and there's no NO2 on the right side for it to cancel out with. So this is correct. If we add this, we'll check the Cl2. Is there any Cl2 on the right side for it to cancel out with? No, and there's nothing on the left side for it to add with. So Cl2 is also correct. Now this Cl here, there's another Cl on the right side, so we can cancel this one out with the right side. It's an intermediate, so it's not supposed to be in the overall reaction, and it's not, so that's also correct. And now finally the NO2Cl, there's two on the left, on the right, and there's none on the left, so we can just add them and we get 2 NO2Cl. So the first requirement is satisfied. Now let's check if the rate law is consistent with the slow step. So the slow step is step 1, and the two reactants are NO2 and Cl2. So the rate law is supposed to be, and they both have a coefficient of 1, so the rate law is supposed to be R equals K NO2 Cl2, and it is. This is here, it's right here, and so it's also correct. So this rate mechanism is acceptable because both requirements of rate mechanisms are satisfied. Now let's do number 2. An acceptable mechanism for the reaction 2NO2 plus Cl2 gives you 2NO2Cl is suggested below. Here they gave us 3 steps, and they're asking us to find the catalyst and the intermediate. So as I said, an intermediate is a substance that is formed in a step and then used up in another step, and a catalyst is a substance that is used up in a step and then formed in another step. Now, for example, here we look for an intermediate. We Here we can find Cl to be an intermediate because Cl is formed in step 1 and then used up in step 2. So Cl is an intermediate. And then we keep then here we'll find out that F2 is used up in step 2 and then formed in step 3, so it's a catalyst. And here we'll also look at NO2 F2Cl. It's an intermediate because it's formed in step 2 and used up in step 3. So the two intermediates are NO2 F2Cl and also Cl. These are the two intermediates, and the catalyst is F2. So now let's do number 1. The following mechanism has been proposed for the reaction of methane gas with the bromine gas. All species are in the gas phase. And they give us 5 different steps. One of them is at equilibrium, one of them is slow step, and the other 3 are fast. So part A, in the mechanism, is CH3Br a catalyst or is it an intermediate? Justify your answer. So first thing we have to do is we have to look for CH3Br, and it's in step 3. It's formed in step 3 and used up in step 4. So what is that? Is that a catalyst or an intermediate? So as I said before, an intermediate is something that is formed in a step and then used up in the other step. So CH3Br is an intermediate because it's formed in step 3 and used up in step 4. Wait, I didn't like that. I have to restart. The following mechanism has... Okay, wait, no. So now let's do number 1. The following mechanism has been proposed for the reaction of methane gas with bromine gas. All species are in the gas phase. They gave us 5 different steps. One of them is at equilibrium, one of them slow, and the other 3 are fast. Part A. In the mechanism, is CH3Br a catalyst or is it an intermediate? Justify your answer. So we look for CH3Br. We can see that it's formed in step 3 and then used up in step 4. So is that a catalyst or an intermediate? It's an intermediate because that's the definition of an intermediate. So we'll say that CH3Br is an intermediate, and to justify our answer, we can just say it's formed in step 3 and then used up in step 4. So now let's do part B. Identify the order of the reaction with respect to each of the following according to the mechanism. In each case, justify your answer. So they want the order of something. So for the order, they mean rate law. So as I said in the previous video, for the rate law, we only look at the slow step. So the rate law for this expression would be R equals the reactant times K times the reactants of the slow step. So R equals K times the concentration of CH4 times the concentration of Br. And the powers of both of them are 1 since they both have coefficients of 1. But here, if we look closely, we'll see that Br is an intermediate because it's formed in step 1 and then used up in step 2. So Br is an intermediate, and as like what I said at the beginning of the video, you can never write a rate law in terms of an intermediate. So what can we do to change that? We can try to get something from the first expression. We can try to get something from step 1. So since we know that K equilibrium, is equal to Br to the power of 2 over the concentration of Br, obviously, the power of 2 over Br2. So we know that this is true. So what we can try to get Br from this. So we would get that Br, concentration of Br squared, is equal to K Eq times the concentration of Br2. What I did is I just cross multiplied Br2 to the other side. So we can radical both sides to get the concentration of Br because we want it not radical, we want it to the power of 1. So we can radical both sides, we get Br, concentration of Br, equals radical K equilibrium times concentration of Br2. And we can also write the radical as to the power of half. So let me just take out the radical and write it to the power of half. So K equilibrium to the power of half times BR2 to the power of half. So now that we have an expression for BR instead of just because we can't use BR for the rate law, so we have to put something instead of it. So we have we have this expression to put instead of it. Now let me just free up some space. Okay, so now that we have an expression for the concentration of BR, we can substitute it inside the rate law and to get rid of the intermediate. So that would give us R, which is the rate law, equals K, which is the rate constant, multiplied by K equilibrium to the power of half, multiplied by the concentration of CH4, and finally multiplied by the concentration of Br2 to the power of half. So what I just did here, I basically substituted this whole expression instead of this. So I put this instead of, I put this expression instead of the concentration of Br because they're equal. So what we can also simplify this to, we can say that K times K equilibrium to the power of half, you can say that small k times K equilibrium to the power of half is equal to big K. Because we don't really need to use the values of K, so we can just say that. So the final expression of the rate laws are equals to big K times CH4, big K times CH4, the concentration of CH4, times to the power of 1 because its coefficient is 1, times Br2 to the power of half. So now we can answer the question. Identify the order of the reaction with respect to each of the following according to the mechanism. In each case, justify your answer. So for part I, they're asking for the reaction for CH4. Now the order with respect to CH4 is 1 because the power of CH4 is 1. And so it's 1 here. And for part I, they're asking for the order with respect to Br2. Now the order with respect to Br2 is half, and I just the whole thing I just explained doing it right now. That's what you use to justify your answer. Thanks for watching. Over Br2 over Br2. Wait. Whoever is editing this, let me just restart the whole thing. I have to use a different color. Oh, this pink visible. Okay, blue is visible. Okay. So if Br squared is equal to K equilibrium times Br, then we can radical both sides. We would get Br. Wait 1 second. We would get Br. Oh, I have to restart the question, bro. Whoever's editing this, I'm sorry, but this question is fucking too much talking, and there's not much space to write. Wait, let me try to get a better screenshot. Yeah, this is worse. Here. Kimo, can you cut this bit out? Wait, Kimo, actually cut this bit out, yeah. 1 second.